Things. Yeah, so I'm going to talk about web components without your favorite framework. So a little introduction about me first. I'm Claire, as Brian said. That's my Twitter and my everything else handle. You can find me on Slack, on GitHub, and everything else by Claire Bones. And I'll be around here all day in the bright yellow hoodie, so I probably won't be that hard to find. Okay, so to start off, what do we mean by web components? What are we actually talking about? Because I feel like it's one of those things where the term is thrown around a lot, especially in front end, and it can mean a lot of different things. So just to make sure we're all on the same page, or if this is a brand new concept to you, this will hopefully give a bit of an idea of what we're talking about. So this is a quote from webcomponents.org. Web components are a set of web platform APIs that allow you to create new custom, reusable, encapsulated HTML tags to use in web pages and web apps. So if you saw the talk this morning on micro front ends, you will have seen the same quote from there. Basically what that means is that web components are essentially building blocks for the web. They're reusable, which means that you can build them once and put them pretty much anywhere you want. If you're making a bunch of different sites, a bunch of different apps, you can use them all over the place. You're not writing the same sort of functionality over and over again. They're custom, so you're building exactly what you need for your site. You're not just sort of trying to hack together what someone else has made. I mean, obviously you can do that as well. And most importantly, they're encapsulated, so whatever functionality you write, it comes with the thing. If you want to write a login form, or you want to write a button that does something in particular, whenever you move that to the next app and the next project, that functionality comes with it. You don't have to write that over and over again. And it means that your sort of container app, the big thing, shouldn't need to worry about all the tiny little details about how your component works. When you slot it in there, it should work like it's supposed to work, like it's worked everywhere else. So there's a couple different ways to implement web components, based on, I guess, your level of familiarity and just what your sort of needs are. The sort of more traditional options, more traditional frameworks that everyone sort of knows and either loves or hates, but probably has to use either way. So with React, you can't really build web components specifically in React, but React will work with your web components. So if you have a big app and it's what you work on or in your spare time, you can start using web components and just integrating the two, and it shouldn't face any barriers because it'll just treat it like it treats anything else, a video component or a button or anything else that's native HTML. With Vue, and the same with Angular there, they have options. They have, especially with some of the newer versions, where you can sort of compile your components that you build in those frameworks so that they act like web components. But as far as I know, I don't have a whole lot of experience with it at the minute. You still would need Vue or Angular in your sort of overall project, in your parent app, for those to work properly. The browser can't really understand them. Svelte, on the other hand, which is maybe not a traditional framework because it's quite sort of small and quite new, but I'm kind of a fan of it. The whole purpose of the framework is that it compiles away to not existing anymore. So if you write your components in Svelte, once you compile them down, they are just JavaScript. They're vanilla. They don't have anything else, which has the benefit, like a lot of these web component ideas do, of you're not pulling an entire, I don't want to pull in all of React because I wanted to write a button that works slightly fancier, or all of Angular because I wanted a form that had some nice validation in it. I don't want a whole framework for a single component, especially if I'm going to use multiple components in that page in the end. There's also a lot of web component libraries. So these are libraries that will sort of be a good starting point if you have no idea what you're doing with web components, but you want, you like the idea, and it seems really handy, or it seems something that you want to try out. My most experience is with Polymer Elements and Lit Element, which are both from Google. But basically these will help, they'll help you get started, they'll help you sort of figuring out what you're doing, and a lot of them come with loads of pre-built components. So that if you're getting started, you don't maybe want to have to start and sit down and write all the functionality for every single tiny piece of thing, like a card and a form and everything else. So those libraries will help you get that, and a lot of them come with some styling, so you don't have to sit and write all your styling from scratch either. Or what we're going to talk about today in a bit more detail is native web components. So this is writing without any help. We're pretty much just writing pure vanilla JavaScript. The things that you need, that your browser needs to be able to handle, which most do. I've got a support sort of graph later on that you'll see. They need to be able to support custom elements, the shadow DOM, and HTML templates. So these are sort of the three core technologies to come together to enable web components, like native custom element web components, to work. But it means that you're writing pure JavaScript, so your browser doesn't need loads of big, JavaScript files to know what's happening. You don't need huge, like 30-odd imports just to get one small thing working. And it also means you don't need any like build steps. You don't need Webpack, you don't need Babel, you don't need all of those things, because it's JavaScript and the browser already understands it. You just write it in those files and load it into your browser and you're good to go. You're ready to start, which is really nice, because for performance reasons, having to not pull in loads and loads of JavaScript is just a huge benefit. You'll be pulling in small files for each of the components that you write, but with things like HTTP2, we can pull those all in together. We can do lazy loading. We only pull them in when we need to. And it's much more performant than pulling in one huge, big, giant file with everything in it that we might ever need, and a bunch of stuff that potentially we don't even need. So, okay, how do I do it? If I want to say, I'm going to write a native web component, I want to do it from scratch. I've never done it before. I don't want to pull in any fancy libraries. I just want to do something super basic just to get started and have something on the page. I'm going to take you through, not a live demo because I didn't trust the internet in here, but some screenshots of code that will do the same thing. And there's a link to a demo, so I'll share the slides afterwards and people can play with it on CodePen. So to get started, a custom element always extends an existing HTML element. So here I'm extending an absolutely basic HTML element, like it's not really inheriting anything in specific. What I'm going to put, it's essentially a div, and I can just put in it whatever I want. But you can do this, as it says there, you can do this with loads of things. You can extend a button, you can extend a video, you can extend article, and these will then, you sort of get all the built-in functionality that those already come with. If I extend video, my browser already knows how to handle videos. I don't have to write that from scratch, but I might want to add fancy styling or extra buttons or annotations or things like that. So when we first set it up, we say what type of element we want to extend. We set up our constructor and hit super there, and that just basically says everything that I'm extending I want to inherit. Whatever that sort of HTML element can handle, I want to be able to handle it in exactly the same way and not have to worry about it. So yep, the next thing is we need to attach the shadow DOM to this new class, this new element that we've made. There are two options here of how we can do this, in open mode or closed mode. So an open mode means that the rest of the JavaScript can see into my element. So if I want it to be able to manipulate and do stuff like in my wider app, I want to set that to open. If I don't, for example, if I'm making a component that I want to be able to share with loads of people, but I don't want them to change how it works or maybe see the inner workings of it, I can set that to closed. And it means that it can sort of, it can interact, it can be passed values and work with them, but the wider page won't be able to see what's going on or how it works or what it does internally. And then what I want to do is append this to, like I will have set up basically a div from that previous slide there where when I extend it, I just want to create a basic div, and then what I'll do is append the template. I'll get onto a slide of what the template for my basic component looks like, but all you have to do is append child. You can also do this from like files and stuff. Okay, so then what we need to do is say, okay, I'm probably not going to extend an element or create an element that doesn't do anything or be passed in any data. So what I want to do is set up some getters. In this like super simple example, I'm just passing in my own name. So I'm going to say, okay, you care about name, and whenever I want to get that attribute, either send me back the name, send me back the value that's been passed in, or send me back something empty so that I can handle it and know what to do with it. And then more usefully, I can watch attributes. So I can say, okay, if I'm passing in name, I want to observe that, I want to keep track of it. And then I get a callback. So I can just run this callback for each attribute that I'm tracking and say, okay, this is what I want to do. This is the name of the attribute. This is the old value of what it used to be, and this is what it has changed to. And then I can run that. So this is pretty similar to how you would do things in React or a lot of other frameworks. You're going to get those lifecycle hooks that says, okay, something's changed, and now I want to do something about it. There's 3 other lifecycle hooks. So can run whenever our element is connected to the page. That's the first one. We can say, okay, my element is loaded, it's in the page, it's ready to go. Like a lot of frameworks, the sort of downside with this callback is that it runs a lot of times. You can get that callback, but actually your page hasn't finally loaded or something else interrupts it. So you might get that a couple times. So you want to be sparing about what you're doing in there, that you're not sort of loading that up with loads and loads of functionality. Ideally, most of your functionality will either be set in your template, it'll be in your bigger page, or it'll be running whenever your data changes. And maybe you need to sort of rework the way your components work so that they're not running a bunch of stuff as soon as they land into the page. The next thing is the disconnected callback. So if I remove my element from the page, like say I have a to-do list and I want to remove those elements, I say, okay, I've done that, I want to check it off, I don't want it to be on this page anymore. I want to be able to run something when that happens. I might want to update my tracking of how many things I have left to do. I might want to send it somewhere else to a different archive or store that data in some way, so I can grab that callback. And the third one is if the elements move to a new page. So this is maybe a less common one, but essentially if I want to say, okay, like I had it on this page, I've moved it elsewhere, but within my same app, I need to be aware of that, and I need to maybe do something that maybe changes context, or I want to show different data depending on where it is, or I want it to have slightly different functionality. So yeah, and then, sorry, excuse me. The last thing I need to do in the JavaScript side is say, I've built an element, I've written it, it knows what it looks like, it knows what it should do whenever things happen, or whenever things stop happening, whenever things change. And now I'm ready to tell the browser, hey, this exists, it's a thing, it's happening, it's right there, you can start and use it. Your browser will hold a list, essentially just an array of custom elements, and that's sort of there by default, and all you have to say is this exists. And what I need to tell it is what it will be referred to in the HTML as, so in this case it's my-element, and then what class to look at. So whenever we set up our class a couple slides ago, if I can jump back without this being super slow, yeah, we just named our class, like my super creative my-element class. You can obviously, pick something that's semantic and makes sense for what you're using, and then all you have to do is say, yes, that's the one. Whenever you see the first value, the my-element, I want you to call the second value my-element class and attach those two and link them up and say, yes, this is what runs when this appears on my page. So the next thing then is the HTML. So when I'm using this in the HTML, I just have to declare it like I declare any other element. The one thing that I've noted here is that you have to have a dash in the name of your element, so that the browser doesn't have some clash. Like I couldn't make an element that's just called button or video or div or anything like that, because those already exist. So to prevent any risk of clashes for custom elements, you need to have a dash in your component name whenever you make them. But usually what most people would be tending to do is namespacing their elements, especially if you're working within a larger system. So you're probably going to start off with, like if I work for Bazaar Voice, maybe I might have like BV dash whatever, or if I work for the BBC, they have like a language system called GEL. So they would be like GEL dash article, GEL dash share button, things like that. So it's sort of, it keeps your page more readable as well. It means that you sort of, as soon as you scan down your page, you're going to be able to spot these are native elements, these are our elements, these are something that we've put in here that are probably controlled from somewhere that I can go in and change and inspect and look at. And then I've mentioned here, so whenever we were attaching the document to the class, in this example, I just used a string literal template because it's really only 2 lines. But what you can do, which is sort of keeps it clean and organized, is to keep separate HTML files. So like you can use proper HTML templates, so either in separate files or in your HTML document. If you want something that's a bit more complicated, it's maybe not ideal to have everything in one giant page. On the other hand, some people prefer, if they're writing web components, to have a single file for a single component, in which case you could have your JS, and then you've got a template inside that, which is your HTML, and inside that you can have your styles. So if you want to just be able to say, just grab that one file and it'll tell you absolutely everything, what I am, what I look like, how I work, then you can do it that way around. Okay, I'm losing my screen. There we go. And then the CSS is the last bit. So the CSS is scoped to our component, which is really, really handy, especially if, as we were saying, you want to be able to use this in multiple places. For example, one of the teams I'm working on in my job at the minute, we're making a component library. So we want to be able to hand that off to every other team in the company and say, okay, this is exactly what this thing should look like. You're making a table, it should look exactly like that. You're making cards, they should look exactly like this. This size, this box shadow, this border, everything. And we don't want the CSS that they've put in their app in general to control what we've written inside our own component, because someone's already signed it off and is going to come raging down the corridor if some other app decides to change it, like when they have been told that they're not allowed to. So you can sort of see in this example, the code on the left-hand side is the page-wide styles. So I'm sending like an H1 with the color of red and an H2 with the color of blue. So the top level there that says NIDC demo, if you remember from the previous page, is an H2. Or sorry, the NIDC one is an H1, then the hello and the my name is Claire are inside the component, which is an H2 and a span. So if I set my H1 color, it's not inside my component, so it's going to follow the styles on the left, which are from my full page. But then on the inside, I've set my H2 color to purple, so it's going to ignore my styling from outside of the page and follow what's scoped to the component itself. If I don't have anything written that's scoped to the component, then it should inherit from the page in general. But if I've got scoped CSS, if it's CSS specific to that component, then it should know and it should follow that. And it also means that you're not then having to write loads of super nested CSS for every single component individually to say, okay, I want you to do this and this and this, and filling up your main CSS pages. So browser support, it's sort of hard probably to see that from the seats, but the main thing to take away is that there's loads and loads of green. But unfortunately, on the very right-hand side, where Edge and the same for IE, there's lots of not green as well. So if you want to use this in Edge or IE, you will need polyfills, which is why I stick this in the implementation section. But the polyfills exist, they're out there, they're not super hard to find. And there's lots of tricks around browser detection and stuff now, so that you don't have to include all those things for other browsers if you don't want them. But it's just to ensure that what you run in everything else smoothly, you can also run in IE. And this sort of covers desktop, but the mobile platforms follow pretty much the same standard, except the Opera Mobile sort of isn't fully implemented yet either, but I believe it's in progress. Okay, so we sort of covered like, what am I doing? How do I do this? So the next question is, should I do this? Like, that maybe seems like a lot of work for a piece of like 3 lines or 2 lines on a page, but that's sort of a super simple example. So there are definitely downsides. It can be difficult to get started. It can be difficult to sort of know, okay, where do I start? What am I doing? Do I literally just start with the very basics? Do I want to write a whole thing all at once? Like if you're building a full library, a full system, that's loads of stuff to start with. And it can be really difficult if you already have an existing app or an existing component library in your company or in whatever project you're working on, to sort of start like replacing that, because like you're never going to get sign off most of the time anyway to be like, I'm just going to rewrite our entire app in this new technology that none of you have seen before, but trust me, it's great. So it can be really difficult to say, right, this is what I'm just going to do, I'm going to throw everything away and start again. But there are ways around this. Like we talked about earlier, you can start integrating web components with your existing frameworks and with your existing projects. You can sort of start sneaking them into things so that you're using a little bit less of the framework, but you don't need to replace it. You're not going to have clashes there. It'll still understand what's happening. The benefits, which is a way longer list, which is why you can tell that I really like web components. And my favorite one at the top specifically is that you don't need big frameworks. Like you don't need React, you don't need Angular, you don't need Vue, you don't need these giant things that are going to take loads of memory that are going to have to be pulled down by your user. Whenever you can build all that stuff into your own components, and it means that you're not pulling down a bunch of extra functionality that's actually not anything to do with what you're doing on your own page. You're not pulling down like massive state management and all the rest of it that you maybe don't even need. You also, as we mentioned earlier, don't need like Babel, you don't need build steps, anything like that. You could just stick these into the browser and they'll work because the browser already knows what to do with them. Which is really nice from a development process as well, because it means you don't have to run through those like, I hit build and now I have to wait 20 minutes while it installs all my npm packages and starts again and figures out what it's doing. Components can be used across multiple sites, so this is the main reason I think a lot of people use web components, because they're reusable. You're making the same thing in loads of places. For example, if I want to say, okay, I work for like YouTube, I have loads of different pages and there's loads of different versions of thumbnails all over the place. I want to be able to say this is my thumbnail component. I don't want to have to write that into every page slightly differently. I just want to say, okay, that's what it looks like. There it goes. It's in there. It's already going to work. It's already going to know what to do. All I have to pass it is like a video image and a video URL, and that's I'm done. They're also specifically customized to your needs. So rather than having to go, okay, I found like some npm package that's kind of like the component that we sort of want, and then we're going to spend like half an hour hacking at it to make it look a little bit different so that it works like what I want it to do. You're building these from scratch, so it might take a little bit more time to get started, but they're going to be exactly what you need. And then you can also make iterative improvements. So because these are web components and they're stored in one file, if you find that you need to make a change, you're not going into all your apps and all your places to make that change. You made it in one place. And each time that you use them, your apps are just going to pull in the files and they're going to know how to work. You're also, because we're extending things, this is another one of my like super huge benefits, because you're extending things that are native to the browser, you're bringing all those benefits with you, accessibility and all, usability, things that users are familiar with. You've got it all for free. Like one of my pet peeves is if I go and see someone's made like a button in a framework, but it's actually like a span with a div around it and then another div around that, and there's no button anywhere in there. So my browser doesn't know it's a button, my screen readers maybe don't know it's a button, and I have to then manually code in like lines and lines and lines of stuff to say, hey, you should do what a button does. Whereas this way, I can totally style it to be exactly what I want it to look like, but it's still a button, so the browser still knows what to do with it. And this is exactly the way that your browser itself manages like more complex native elements. So I think this slide might be slightly hard to see, but what I've done here is just inspect YouTube. So the top line is what you normally see. If you just right click inspect, on YouTube you'll see a video element. But what you can do is you can go into your DevTools settings and turn on to show the native shadow DOM for native elements, and then you can go in and inspect how that video is made up. So there's a line there about the third step into the bigger chunks that says shadow rip, and everything under that is how the native video element is made up, how it's put together. So you can go in and you can have a nosy and you can figure out how it works. This is obviously because, as I said, this is sort of set to open and people can see this, but it's sort of nice to know that if you're writing components, they're being written in the same way as the browser components are written, and it gives you more of an insight into how that's all put together. So I've put some resources at the end, so I'll try and share out these slides. These are sort of the three main points of where you should go for a bit of info. If you want to get started, the Google Developer Docs and the MDN examples are great. And webcomponents.org also has loads of examples of libraries to get you started, loads of tutorials, loads of projects that other people have worked on that use web components. And yeah, that's me.